Hey there, everybody. Thank you for joining us. Josh, are you there?
Yes, I am. Really appreciate you and your team. And of course, everyone from our Soligent universe. Thank you so much for joining us as a part of our Soligent Storage webinar series. And of course, our extremely valued partners at Fortress Power, they're here to teach us about how to sell commercial industrial energy storage solutions today. It's going to be very exciting, especially as we unlock these big opportunities. I get a call almost every other day from one of you in the field that your customers, especially business owners, are getting nailed with demand charges. And on a commercial level, up until now, it's been difficult to find the right solution for those customers, but not anymore. Here at Soligent, we have the solution from our partners at Fortress Power. And so without further ado, I'd like to let you know, number one, you're not alone throughout this entire process. So email me storage@soligent.net anytime throughout the broadcast today or afterwards. And we'll contact you to schedule a meeting with Alex, Kyle, Matt, and the Fortress Power Commercial Industrial team to review your customer's project, their 15-minute interval data, get a checklist for you to fill out. And with that information, we will be able to customize a turnkey solution for your commercial industrial project. It's very exciting these days. We can actually offer not just some solutions, but solutions for everything. The scalability, we're going to go into all of that. The customization, we're going to go into all of that. Actually, Kyle Bannon and Alex Lepore from Fortress Power, our host, kind enough to offer this education for us today. They're going to go into that, and we're going to bring you into a relationship with them on an ongoing basis as we fill out those checklists and we talk about the different parameters of your different commercial industrial projects. The days of turning that business away are over. We've got some turnkey packages available, customized through Fortress Power, available right here at Soligent. Click on the link below. Again, if you have to leave this webinar early, or if you've got teammates or salespeople on your team that have missed it, maybe they're in the field or off today, no worries. We're going to take the recording from today's webinar with Fortress Power and Soligent, and it'll be available as Soligent Storage webinar series at the Soligent YouTube channel. So without further ado, take it away. Kyle Bannon and Alex Lepore teaching us about renewable energy customized systems, commercial energy storage solutions, how to sell it, how to size it, all that good stuff right here and more. So stay tuned. Alex Lepore, Kyle Bannon from Fortress Power. Thank you so much for partnering with us here at Soligent.
Thanks, Josh. We're glad to be here. For those that don't know me, I'm the sales director here, but the brains of our operation is going to come from my very own colleague, Kyle Bannon, who is our sales solution engineer for the commercial products we're going to present today. So if you guys have questions, stick them in the questions chat. We'll do Q&A at the end of this. Without further ado, Kyle, let's hear it. Thanks.
Thanks, Alex. Yeah, my name is Kyle Bannon. I'm the C&I sales engineer for Fortress Power, based out of Los Angeles, California. We got some really cool stuff to talk with you guys about today. For those of you that aren't familiar with Fortress, we're going to give you just a little spiel, who we are, what we're about, how we came to be the energy storage company that we are today. We're going to talk about the market, how we see the C&I energy storage market shaping up and who we want to be in that market. We're also going to talk about how we approach jobs in this power class, right? We want to be more than just a battery manufacturer, more than just someone who sells you batteries, and we'll get into that in just a minute. We're going to talk about our hardware options. We have two commercial and industrial energy storage options to talk through with you today, one being the Espire 280 and the other being the Espire Mini. We do have data sheets for those products on our website if you'd like to look them up before we get into the nitty-gritty of the details of those systems. We're going to talk about hardware. We're going to talk about the software that runs those systems, our microgrid controls EMS software. And then finally, we're going to talk about our modeling capabilities, how we look to show these projects make both dollars and cents, right? So I'm just going to jump right into who we are. Fortress Power is a lithium iron phosphate, or LFP, energy storage provider focusing on both residential and commercial applications, really from 5 kilowatt hours, smaller lithium batteries, all the way up to 4.2 megawatt hours of energy storage. Just a couple things about Fortress. We're headquartered just outside of Philadelphia, Pennsylvania, in Langhorne, PA, so about 35, 40 minutes north of the city. But we've got offices all over the world, really. We've got an office in California, the Los Angeles office, which is where Alex and I are based out of. We've got an office in China as well, and then we've got an office in Puerto Rico in addition to our headquarters in Philadelphia. We were founded, our first full year in operation was 2017, which 6 years in the battery space, it's kind of like dog years. It might as well be 15, 20 years. Alex has been here practically since day one. He's seen and done a whole lot in this market, in this industry. We've seen battery companies come and go, so we see the pitfalls that other energy storage companies can run into. And we see what works well in the industry. So I think we've in our short time in this industry, I think we've learned a lot, and we've been able to put together a portfolio of really good products and good support to back it up. This says 20,000 plus installs, but I think it's over 30,000 plus at this point in North America, Canada, the Caribbean, South America, really all over the world. We've done energy storage projects, but we're a top 5 residential energy storage provider, lithium battery provider for a number of government institutions and utility companies that have worked with us and continue to work with us today. It's not just a one project and done. They see the value that we bring, like I said, in the hardware, the software, and the engineering support. So to name just a couple of the companies and institutions that we've worked with, down in Puerto Rico, the Puerto Rico Department of Housing, there's a low-income housing project that over 5,000 homes are using Fortress Power energy storage on the residential scale. But we've done projects like banks, Banco Popular in the Caribbean. We provided energy storage to Hydro-Quebec up in Canada, who has their own energy storage division. We've been able to find products that make sense for their applications for Hydro-Quebec. The first project we ever did was actually a commercial job for SEPTA, Southeastern Pennsylvania Transit Authority. So they run the subway system and train system in and out of Philadelphia. We did battery power for some of their backup battery power for some of their switching gear stations. So that was back in 2017, but even today we have projects that we're working on with SEPTA because they trust us and they know we're going to get the job done. We also do fully off-grid jobs out in New Mexico. We did a project for the Navajo tribe. They are their own utility out there essentially. So over 200 homes using Fortress Power energy storage. So this is by far not inclusive of all the companies we work with, but these are just some of our trusted partners that we work with to and continue to work with in this space. So that's kind of who we are as a company, what we've done. Now I want to talk about, like I said, the market, where we fit in, how we see it today, and some of the issues that come along with that space. So as far as we see it, the market for commercial energy storage, it doesn't offer a ton of options for the space, that green bubble right above residential, right below utilities, called from 200 kilowatt hours up to 5 megawatt hours of energy storage. However, there are a ton of applications, right? Just a couple of them listed at the bottom. Peak shaving, time of use arbitrage, grid tied backup for places like grocery stores that can justify resiliency, schools, again, that need to keep the lights on when the kids are in school, agricultural facilities that get hit with really high demand charges, and they have really spiky load profiles, which lead to huge power bills. A ton of applications in this green bubble, but not a lot of options on the market to fill it. So why do we think that is? The reality is that the companies that can do these jobs, 500 kilowatt hours, a megawatt hour of energy storage, they're the same companies that are doing 5, 10, 20 megawatt hours of energy storage on the utility scale. And the fact of the matter is, the reality is that they just make more money doing those larger projects where the engineering is going to be very similar for both sides of projects. So if you're going to be doing the same amount of engineering work, you might as well be making more money. That's why they're practically blowing off people in this green bubble to focus on the jobs in the higher power class. So that's not a great feeling for customers getting blown off, especially for someone else, right? On the residential side, right, you can stack 48 volt batteries and 48 volt inverters to get to some 300 kilowatt hours of energy storage and 60, 70 kW of inverter power. However, at a certain point, the complexity of that system and just the amount of engineering and a number of different companies that you need to work with to make that system work, there's a trade-off that happens right around 200 kilowatt hours where you're probably better off just getting a larger system. right? One piece of equipment versus 4 or 5 stacked pieces of equipment. So ultimately, that's kind of the opportunity as we see it. We want to fill that green bubble with something that's medium size, right? Think not a 20-foot shipping container that you need a bunch of footprint for, something that's a little more flexible in how you can get it on site, something that's modular. So think, Lego building blocks that we can scale up or scale down depending on how much capacity you need, how much power you need, and something that's as plug and play as we can possibly make it, right? So similar to a gen set, you put this thing down on a concrete pad, you hook up the connections, you turn it on, and it's good to go. That is what we're trying to be at Fortress Power. So that's the market, right? Now, like I said, I want to talk about how we approach these projects in this specific green bubble. Like I mentioned at the beginning of the presentation, it's easy for someone to say, hey, here's a battery, go figure out how it fits into your system, right? Here's just a battery cabinet, no inverter, no controller, no software, nothing. Or they'll say, here's all the hardware that you need to make it work, right? The battery, the inverter, the balance of system like grid sensing relays and islanding equipment. But they'll say, oh, well, microgrid controls and software, EMS, energy management system software, that's not our bag. You have to go to a third-party microgrid controller to do that. That is not what we want to be. We want to be truly a one-stop shop, one hand to shake, all the corny analogies you can think of. We want to be one company under one umbrella that you can go to for your energy storage project. So think of this green circle as a menu, right? From whether it's system design and financial modeling, a la Energy Toolbase, all the way through to fleet management and O&M support. We are the energy storage experts, and we know the equipment that's going to work well with our systems to be able to make sure it's all going to work in simpatico, right? So like I mentioned, energy Toolbase style modeling. You give us 15-minute interval data, you give us your rate structure, and we'll be able to build in what your payback period is, what your rate of return is, so that you can make sure that these projects make sense, right? Pre-engineered NEC compliant products. We can select PV inverters, gensets, other pieces of equipment around our microgrid, around our energy storage system that ultimately we know is going to work out of the box with our system. On-site commissioning support. We will send an engineer to site to oversee the installation process and perform that startup commissioning for you. And then last but not least, fleet management and O&M support. We have an online dashboard that you can view how your system is operating at any given time and make sure that you're planning O&M properly so that you'll be able to get the most out of your system. Like I said, we realize we are the energy storage experts. We want to work together with you to take as much of that off your plate as we can. So that's the really how we look at the market. That's how we're looking at approaching these projects. Now I want to talk about the hardware of the system. So this first product that you're seeing right now is called the Espire 280. That stands for 280 kilowatt hours of energy storage. So that's essentially this battery cabinet that you see in the center here, 280 kilowatt hours. On the right-hand side is a 125 kW inverter. We can put 5 of those inverters together to get the 625 kW of 480 volt power. And we can put 3 batteries to each one of those 5 inverters to get 15 total battery cabinets to a single feeder. So that's roughly 4.2 megawatt hours of energy storage. To give you an idea what that looks like, up in that top right picture, that's 6 batteries on a concrete pad. So roughly 1.7 megawatt hours of energy storage. Like I mentioned, it's not a 20-foot shipping container. It's more flexible in how you can get it on site. If you have the space for a gen set, typically we can fit the energy storage system in there as well. And that goes to that second bullet point there, right? Easy and flexible to scale, modular design, being able to give you just the energy storage and power output that you need, not have to oversize the energy storage system. That will ultimately tailor make the system to your project and save you money as opposed to an oversized system. One thing to note about this energy storage system is that it is liquid cooled, right? So versus an HVAC, an air conditioning unit blowing on the cells of the battery to keep them cool, it uses an integrated liquid cooling system. So there's no external water lines. Just uses ethylene glycol to remove heat from the cells of the battery. It's essentially a heat exchanger unit. So what that does is that extends the life of your system. It's 3 times more effective, that liquid cooling system, at removing heat from the cells than just HVAC fans blowing on the system. So the standard warranty for this system is 10 years, but with the liquid cooling system, we're anticipating the system lasting much longer than the warranty, obviously. And it depends on how aggressively you use the battery, right, in terms of cycles per day. But it is rated for 6,000 cycles at 90% depth of discharge. So at 1 cycle a day, that works out to about 15 years of use out of this system. And credit to that liquid cooling system. That really is the future of energy storage. Just talking bigger picture, liquid cooled batteries are ultimately the future of efficient energy storage. Talking about microgrid controls and EMS software, that cabinet on the left-hand side, the last piece of the Espire 280, that's our microgrid control cabinet. That houses really the brains of the system. That's our special sauce on the CNI side. We have the microgrid controller, which is talking back and forth with PV, talking back and forth with gensets. Can handle any sort of microgrid application that you can imagine, right? Whether it's grid tie backup, fully off-grid microgrid, peak shaving for demand charge management. It can also do virtual power plant demand response programs from utilities. Everything that a microgrid can do, this can do out of the box. And that's, I think, one thing that sets us apart from other energy storage providers. There are some providers have certain limitations, right? They say, oh, well, we can't go fully off-grid, or we can't do demand response. We don't have OpenADR 2.0 technology. We do. We have all this stuff out of the box ready to go. And whether or not you're using it on your specific project right now, say 5 years from now, your utility rolls out a virtual power plant program or demand response program. All we have to do is turn on the relevant software capabilities within the system, and all of a sudden you're participating in that program. So this system is not only good for today, it's future-proofed for tomorrow. And last but not least, that advanced fleet management screen. I'll show you guys what that looks like in just a sec. How the online dashboard that allows you to view how these systems operate. So super rudimentary line diagram here, just representational visual approach to how we AC couple these systems. So that's good to note. This is going to be an AC coupled system for the time being. DC coupling is in development, but for now the Espire 280 is going to be AC coupled only. So you see here the grid power coming in from the left-hand side of the screen. Typically going, stepping down from grid voltage to 480 volt. We are typically AC coupling to a 600 or 800 amp distribution panel, the same panel that is typically connected to the PV inverters are connected to. So we're able to operate the PV when there is an outage. It's helping to energize that system. And then you can see the green lines there from the PV inverter and from the PCS to the microgrid control cabinet. We're sending all the data from CTs, all the production data, feeding it to our control cabinet and feeding it up into the cloud so that you can view it on that online dashboard. So, but in a nutshell, very simply, this is how this system is going to AC couple to feed the loads that are on the right-hand side of that distribution panel. So now I want to talk about a project that we installed up in Northern California, in Eureka, California. This was at a school district site. So they're in PG&E utility district. So one of their main considerations was because of these rolling blackouts that happen in PG&E, we want to be able to keep the lights on when the kids are in school, right? So this is a fully islanded system. It's grid tied, but it can island from the grid to provide battery power to a critical loads panel in those outage situations. In addition to that, it also, because they were adding a level 3 electric bus charging station, you can see that at the bottom, they realized that their power demands, how much power they were using from the grid, was going to spike. It was going to cause a rise in their energy bills. So they said, well, why don't we enable this system to also be able to do peak shaving for demand mitigation, essentially, from that extra bus charger. And this is just the first charger they're adding. I'm sure that they have plans to add more in the future. So they realize the value in being able to mitigate the demand from extra equipment using power on their grid. And I think this is something that a lot of customers are going to need to think about in the future. Don't just think even in the next 5 years, but in the next 10 years, think about electrification. How many more EVs are going to be on the road? How are you going to have EVs? Are you going to, is this facility going to want the opportunity to have extra power? Do they need to mitigate that in some way using energy storage? So the point is, for this, being able to stack the value of peak shaving plus backup power or virtual power plant plus getting the most out of your solar system, find ways to stack that value, because it makes it the project's pencil at the end of the day. So that's our larger system. That's the Espire 280, 280 kilowatt hours is the smallest building block, 125 kW output, 280 kilowatt hours. Our smaller product, which just came out this year in February, is called the Espire Mini. And these are, two different products for two different areas of the market. They overlap in terms of capacity and power output. And we like that because it gives us options. And, if you have a specific project that has certain constraints, we can recommend one product or another that makes sense based on what you're trying to do. But just talking about first and foremost, obvious differences between the Espire Mini and the Espire 280. Espire Mini is just one box. What you see is what you get there. The batteries, the inverters, an ATS, some additional equipment is all built into that one box versus the Espire 280, which is going to be 3 separate boxes. This system can do 3-phase 208 or 480 volt without an external transformer. It does depend on which inverter segment you check. If you need 30 kW of inverter power, that can do native 3-phase 208Y without an external transformer. If you need to output 60 kW or 90 kW, the other options for inverter power out of the system, you will need an external step-down transformer to go to 208. But regardless, the system won't require an isolation transformer. It's always going to output in Y configuration. The same exact microgrid controller and EMS software is in this system as in the larger system as well. So all the different applications you can think of. This is just a microgrid, the same microgrid you'd get with the larger system, but in a smaller footprint in one box. One, again, major difference between this system and the Espire 280 is you can DC couple this system. So there are actually DC to DC combiner, or I should say DC to DC MPPTs inside this cabinet, and I'll show you in a sec what that looks like. But we can DC couple up to 135 kW of DC power into one of these directly into the Espire Mini. What's great about that is you eliminate the need for a PV inverter, right? So you can, as long as you size your strings appropriately, you can feed them in directly into the Mini, reduce installation costs, reduce lead times that come with PV inverters. I know some of the lead times for certain inverters has been off the charts. I think it's probably stabilized now, but just know our whole goal with this is to be able to consolidate equipment and eliminate extra equipment like PV inverters, like external transformers when we can. Another major difference between this system and the Espire 280 is this system is air cooled. So where liquid cooling, right, is the best system to keep your system in operation for long periods of time. This system still has an air conditioning unit. It's still cooling the cells, but it is more cost effective in that it's not a full-blown integrated liquid cooling system that was built into the design of the system. So more bang for your buck. You can still have a microgrid in a box without having to pay for, you know, the Ferrari of microgrids that is the liquid cooled system. This system can be indoor or outdoor installed. Indoor installation can be tough because you have a lot of code requirements, and you have to, we do, you know, it passes all 9540A and UL 9540 tests for you know, thermal runaway and compatibility with the inverter. However, you still are beholden to the inspectors, the local jurisdictions. So if you can fit it inside per the code, great, it can go inside, no problem. But it's also NEMA 3R, so it's fully equipped to go outside as well. So talking about scalability for this system, right? This is what the inside of the cabinet looks like. I mentioned 30 kW is the smallest inverter segment, and 81 kilowatt hours is the smallest battery segment that you'd have for this. So 30 kW, 81 kilowatt hours versus the 125 kW, 280 kilowatt hours for the larger system. So it's modular in that on the left-hand side of the cabinet, we're just sliding in battery modules as needed to get to the capacity that you need. In the top right, the inverter segments are modular as well. So 30 kW, 60 kW, or 90 kW. That's however many inverter segments you have, that's much power you'll be able to output from the system. Right below that are the 45 kW DC to DC modules. So they can each take in, I believe it's 2 strings. So each one has 2 inputs. So you can have up to 6 strings in a 135 kW cabinet when you have 3 of those DC to DC modules inputted. So gives you some flexibility, right, in how you can design your solar. And again, the whole goal is to be able to eliminate the PV inverters when we can there. This has an automatic transfer switch built in to go from grid following to grid forming mode and vice versa. It is a static transfer switch, so the switching time is about 30 to 40 milliseconds, which it's not a UPS system, right? It's not like less than 10 milliseconds that's required for some data center operations or hospital scenarios, but we can pair it with a UPS that would handle, say, the first 5-10 minutes of those critical functions so that then the inverter can form the grid and we can switch that battery power back over. And it's got all your, you know, load side, grid side, inverter side circuit breakers here as well, so that we're not over amperage there. So that's a rendering, right? I want to show you what that actually looks like in our facility. This is a fully loaded cabinet, 266 kilowatt hours of energy storage, 90 kW of inverter power at 480 volt, and 3 DC to DC modules to give you 130 kW of DC coupled solar. And again, like I said, same exact microgrid controllers, same exact EMS controls. And I think now it's a perfect segue to go into what that how that works. How do the EMS controls add value to the system? Why are they so important? When we first went to market with our systems, our commercial energy storage systems, we were saying, here is all the hardware, here's the balance system, here's our engineering support, but we don't do microgrid controls. That wasn't our game. What we realized very quickly is that can add some frustration, some consternation in terms of making sure the equipment works together properly. You're going to multiple companies to get the system put in, so there can be some finger pointing if something goes wrong or you're helping to troubleshoot. So what we decided is we want to incorporate this in our offering. We actually went out and bought a microgrid control and EMS controls company last year to include that in our offering. So a company called CleanSpark, they focus on Bitcoin mining, and so their microgrid control arm had been in operation for some 7-8 years, focused on really using power most efficiently to financially profit from mining Bitcoin. Last year, Bitcoin took a little bit of a dive. They were in a position to sell that arm of their business, and it was perfect timing. That's when we were looking for the hardware and software on the microgrid control side to pair with our battery storage offering. So we purchased their hardware, their software, that whole business unit from CleanSpark, and that came with, like I said, the hardware, the software, but probably most importantly, the team that was at CleanSpark. That have been doing these microgrid control systems for 7-8 years. Places like Camp Pendleton in Southern California, Rams Hill Golf Course as well in Southern California. So that knowledge and experience combined with their software, and we'll talk about later their modeling capabilities, was a no-brainer for us. It just made so much sense to add the value and tie it again into one umbrella, one company, one hand to shake for these energy storage systems. So if you're not familiar with energy management systems, all it does, like I said, is tell the power where to go and when. What's the state of charge of the battery? Do we need to feed the loads? Do we need to charge the battery? Do we need to feed it back to the grid, depending on what we're getting charged for power and what we're receiving as a result of feeding it back into the grid? All that comes from directly the microgrid control system. To give you an idea of what some of these online dashboards look like, when you go online and say, your specific online website for your microgrid control system, this is what you'd see. The first screen is called the power flow screen. So it's essentially just a power mix, right? How much is my solar producing? How much is my battery producing? How much am I drawing from the grid? What are my loads consuming? Because we have CTs on all the loads, the PV system, the energy storage system, we know how much production is being either sent out or pulled in from the grid or from the storage system. So we can say, okay, here's the data that's coming directly from the source, directly from those CTs. And then we build in the rate structure to say, okay, before you had an energy storage system, this is what you would be paying for power. Now, as a result, you're paying this for power, you're saving this much money per date. So every one of these systems is going to have, how much solar generation and battery generation and how much money we're saving you as a result of having an energy storage system. So this is good for like ESG, right? Upper management, they just spent a bunch of money on this system, so they want to see just a snapshot, how is my system operating on a day in, day out basis? This is a great screen for them to look at. Another great screen, probably my favorite screen in our EMS dashboard, is this continuous optimization screen. So this gives you a visual representation of your load profile, right? That black line is what your power, the facility is using. And then above or below the curve is how we're making up that power mix. So yellow would be solar power generated, red would be coming from the grid, green would be battery power, black would actually be charging the battery from solar, and purple would be sell back to the grid. So you can see at the bottom there the rate structure built in, that purple line, depending on what that rate structure is throughout the day, and especially in like California with NEM3, with the rates changing practically on an hourly basis, being able to rely on the logic of the software to make those decisions when to send the power and where, it creates so much value for the system. It's practically a set it and forget it approach, right? We're going to pre-commission this system before it even gets to site with what load profile data we have. But as we get more data, we can make iterative changes to the system to say, you're using equipment from 9 to 12 a.m. every single day that is 4 or 5 times your power use. So let's make sure we have enough reserve capacity of the battery to shave those peaks. And again, that's just, it's almost like AI is a term that gets thrown out a lot and ambiguously, but it is artificial intelligence in that it's taking in the data, making a decision based off that data, and making constantly taking in new data to make better decisions. So that, and this is just a way for you to see for yourself visually how it's making those decisions. Last screen that I want to talk about for our software is our fleet management screen. So like I said, this is that 30,000 foot view, not just one site, but all your sites, how they're operating. You can set customizable alarms, not for just our equipment, but all the equipment that's feeding signals into our controller. So for example, a PV inverter, you'd have all the PV inverters sending Modbus commands to our controller, and it would say, okay, PV inverter 6 is down. We can send text messages, phone calls, emails to maintenance personnel, to on-site personnel to go out and check the inverters, make sure everything is okay. You can plan maintenance schedules in this tool as well. So say you know PV inverter 5 goes down every 6 months. We need to set a note in the O&M schedule to check it every 4 months, so we're ahead of the game just in case it does go down before then. It ultimately, like I said, is that 30,000-foot view that helps you make better decisions on when to dispatch personnel for O&M and understand the health of all your systems in the field from one place. And last but not least, we can integrate this into your own portal or customer's own portal, so they have a building management system that they just want to be able to look at one website for their genset, for their battery, for their wind turbine, right? They don't want to have to go to 3 different online dashboards. We can integrate it into other people's existing platforms via API or other means to simplify that. So that's the software side. That's, like I said, really our special sauce that we add to these already ubiquitous hardware products. Now I want to talk about our modeling capabilities, because we in purchasing CleanSpark, their microgrid control arm, that came with the models that they had built over the last 7-8 years to make sure these systems make financial sense. So very similar to Homer or Energy Toolbase, you send us 15-minute interval data, you send us your rate structure, what you're paying for power, and we can spit out financial pro formas that say, you know, based off of how you're using your power and what you're being charged, this is what your payback period would be for putting, you know, an optimized solar plus battery storage system. We can tell you what size solar makes the most sense. We can tell you what battery size makes the most sense. We can do it both pre and post tax, right? Taking into account ITC tax credits, SGIP incentives, you name it. We can build in all these incentives to show you as best we can how this project's going to pencil. And one thing to note, the software that's running these models for us is the same exact software that's running the microgrid controllers in the field. So there's no mismatched expectations, right? What you're seeing in the model is exactly how the logic, the algorithms are going to look at the problem when it gets into the field. Now, obviously, there are, like I said, iterative changes that happen depending on the data, and as we get new data that can change. But the main point is you're not using some third-party modeling and then assuming that the logic is going to be similar when it gets in the field, so you may see different payback periods, right? This is all going to be the same software to model and to act on the system. So it's going to show you, right, these pro formas. It'll show you before adding a battery and after adding a battery, what's your power bill look like, what's your load profile look like, what's your energy use, right? There's all different sorts of priorities for customers. Some want to be more green, some just need resiliency, some just want to save money. We can build that into the model and say, okay, you know, we need at least this capacity for an outage. Say we need 25% reserve capacity if the power goes out. We can say, yep, don't ever let the battery go below 25% and try and make as much money as you can. No, those little caveats that are really specific to each project, that's what we want to be able to capture in this model. So that's really where we stand out from, I think, most energy storage providers. We're not just a battery company. We're not even just an energy storage company. We are energy storage and modeling and engineering support for your energy storage products company. We're a vertically integrated energy storage company. So
Hey, Kyle,
that's, yeah, go ahead, Alex.
can you go back to that slide that you just had? I wanted to mention, so, you know, we talked a lot about the, you know, all these features, right? And part of our job, you know, being, whether you're a manufacturer, you're on the distribution side, or you're an installer, whoever you are, we have to convey value based on those features, right? So the value here and the sales, you know, coming back to this all-inclusive or all-elusive maybe, how do we sell this, right? That's like the end question. It's great that we can put together this data modeling, but the sale is very, how do I say, more likely to occur with data of this level, right? Approaching a commercial business owner or someone that has interest in this, we can quantify their investment with this asset, and that really gives your proposal teeth when you slide and have that, I'll call it like dinner table, it's probably more business table conversation with them about, you know, what we're selling you today is going to pay itself off within 10 years from the warranty, for example. You have the aspect of grid resiliency, and at that same token, we can leverage today's incentives and rebates through state or national, so that way you pay a lot less than what let's say the equipment's probably actually worth, right? Because we're able to take 30% tax credit, or you're able to do bonus depreciation or macros, for example. So talking about how to sell it, selling it is part of, communicating obviously the needs and wants of the commercial facility owner or the operator, or whoever that it is we're talking to, and explaining to them, well, what is your goal? If your goal is to save money, here's proposal A. If your goal is to back up your facility, here's proposal B. If you want a combination of A and B, well, here's C, right? You give them options to choose from so they don't just feel like, well, man, they just want to sell me this, really expensive battery and we're just going to kind of wing it. Hopefully we save a couple things. No, we're going to take a very quantitative, logical approach to it, saying, hey, we're modeling this through, the newest technology when it comes to modeling. So try some sort of fancy software word in there. And then that's the proposal. That's going to help you sell this, breaking out, clearing expectations that are not true, managing them, and then selling them what we intend to.
Yeah, well said, Alex. At the end of the day, I think that's a good segue into kind of my last point here. More than half my job is education, right? I'm not going to sell you something that doesn't make sense because neither of us are going to be happy. The customer's not going to be happy. I more than anything want you guys to be educated so that when you see a project that you can say, oh, yeah, that makes sense for Fortress. That makes sense for us. That makes sense for us to work together and get a system that the customer is going to be happy with. Because if we, like Alex said, if we're just, trying to sell you an expensive system, it's not going to make sense. It's not, no one is going to be happy at the end of the day. So let us be your energy storage expert. Let us take as much of this green circle off your plate as you want us to. That's who we are. That's what we're about. And don't take it from us. Talk to people who use Fortress Power equipment, who have dealt with energy storage before, and talk to them about what we're offering and see what else is out there. We think that what we're offering is unique because we are that one-stop shop to help you accomplish the goals of these projects. So with that said, I do want to open the floor for questions. I haven't checked to see if there is anything there that has been unanswered yet, but if you do have a question now, I would throw it in the chat. And otherwise, you can reach out to me, Kyle B as in boy at fortresspower.com, or to Alex L at fortresspower.com. Feel free to send us questions. We have a kind of a process, right, how we approach these projects with a checklist. We try to get as much info as we can about the projects so that we have a way to formulate the discussion around the information that you provided. So if you want us to look at specific projects, connect with us. We'll send you the info that we need so you can fill out, and then we can sit down on a call and talk it through. It is very consultative. I know Josh likes to put his doctor's coat on, that we are doctors of power, essentially. So let us be the experts on energy storage for you.
We're happy to help you, and we're here for you. You're not alone. Kyle Bannon and Alex Lepore, experts and friends of Soligent. If you're working with Soligent, you have the benefit of getting and offering a customized solution for commercial industrial energy storage for your customers, turnkey packages that are personalized. I mean, if you had a chance, a few slides back, they showed the different savings and how they model and how they take into account the different incentives and the rate structure. This is the real deal. There is no guessing, wishing, hoping, and praying. We can know for certain how to save your customers money, how to address the concerns they have with their big utility bills, their demand charges, for their commercial industrial operations. These are 24/7 operations, and they're getting nailed with demand charges every single day. There are opportunities right now to not turn away that commercial industrial business anymore. You can now say with confidence, we work with Soligent and Fortress Power, and we have a solution for you. Let's get it started. So if you're interested in that, and you'd like to partner with us and Fortress Power here at Soligent, email me today, storage@soligent.net. That's storage@soligent.net. We will schedule a meeting with Kyle, Alex, Matt, and the Fortress C&I team to get together with you and your team to confirm all the details, get that 15-minute interval data, the checklist, and your customers' utility bills. And we will customize a solution that will make sense to your customer. In addition, guys, are we like a lot of other manufacturers and businesses out there that just once the quote is done, have a great day, good luck? No, talk a little bit about that. You're willing to go before, during, and after the sale. So that means that as our customers are needing to make these proposals, you will be consulting our customers throughout the process, right? Not just providing a quote. We're here to help you win deals, right, guys?
Absolutely. Kyle, do me a solid. Pull up the alcohol, the brewery presentation. If you can go ahead and pull that up quickly. I think it'd be really great to have the folks here take a look at an actual design that we did for a brewery in Taos, New Mexico, where they were getting hammered by demand rates, and conveniently have it right here. So again, Josh and Kyle hit the nail on the head, right? We need that 15-minute interval data. We need all the information on the site layout in order for us to provide a recommendation that is true with the historical data that we were given. So let's start with step one, data modeling. We had some missing values, right? So we like to try and stay away from that, but we can make assumptions based on their kilowatt hour usage based on other months, right? So going through this data modeling, you'll see they split up the different months. You'll see there's basically summer, winter, spring, fall. They have their usage, the fees, energy in terms of cost, demand in power, and then demand and cost with taxes, and then their total bill, which is then aggregated to that total column, which is, if this was Excel, it's probably M or something down at the bottom there. If you go forward in a slide, Kyle, can you go forward a slide for me? Yep, we have the baseline electric charges. Keep going. I'm looking for one particular slide. Keep going. This is just math. You see annual electricity savings at the bottom.
You're looking for the assumptions and limitations. What do you lead?
The financial breakdown with the NPV.
I don't know if I have this in this presentation. These are the slides that I have for the brewery. Essentially, our modeled charges, right, before adding energy storage. Nice. They were paying about $44,000 a year in demand charges, and energy charges between $500 and $700. After adding energy storage, their demand charges went down to less than $1,000 a month, and energy charges between $100 and $300. So saving 43 grand a year in energy storage just by adding this energy storage system, right? That payback period is probably 6-7 years before tax, before any sort of incentives are taken into account. So you might not be able to understand energy storage or microgrid controls, or the customer might not, but they can understand saving money. I think everyone can understand saving money. So this is just like Alex said, this is what helps us to sell these projects. We can show you just the facts, the data, all the assumptions, any caveats that we make, and say this is what you're missing out on by not adding energy storage to your
Exactly. You sound like a doctor. How often, folks, do you go to the doctor? You take a blood test, you get on the scale, you do your blood pressure, they look into your eyes, they check your breathing and all that good stuff, right? Then the doctor says, I've diagnosed you with X based on all these tests. The tests are saying this is what you have, and here's the prescription that you need to solve your problem, to be healed. You don't see the patient generally arguing and saying, I only want half that. No. At the end of the day, what they do is they trust the expert, the professional, and the facts that were presented to them as results of their tests. So as you provide Kyle and Alex and our team with the 15-minute interval data, the rate structure, the copy of your customer's bills, the completed checklist that shows all the information about the project and your customer's goals, then we will be able to provide a prescription that you can come fill that prescription here at Soligent to heal your customer and provide them with a commercial industrial solution. And just like the doctor-patient dynamic, you need to have a doctor-patient dynamic with your customer and show them the facts. Allow us to join you in the proposal throughout the process in providing that additional value and explaining why it is what it is and what the result is if they go down this course of treatment. Generally speaking, patients don't argue with doctors. They go get the prescription filled. Likewise, if you want to help your commercial industrial customers, treat them like patients. Get their information. Let's get together with the doctors at Fortress Power, and we'll come up with a customized, personalized commercial industrial energy storage solution just for you that will make sense and will help save them money. So I'm excited, folks. If you'd like to partner with us, thank you again, Alex and Kyle. Alex Lepore, Kyle Bannon from Fortress Power's Commercial Industrial Energy Storage Solutions team. We work hand in hand with them here at Soligent. So email us today to partake with us at Soligent's storage email, storage@soligent.net. That's storage@soligent.net. And if you got here late or your salespeople missed the webinar today, you'll see it as a part of our Soligent Storage webinar series that is going to be uploaded at the Soligent YouTube channel. So make sure you get that recording. You can also contact me if you'd like to do this for your sales team. We can do this on a personalized basis. Kyle and Alex are always making themselves available for team trainings as well. So we want to thank you for being here, and thank you so much, Alex and Kyle and Fortress Power, helping us offer these awesome commercial industrial energy storage solutions to the masses as a part of our Soligent Storage webinar series. All right, without further ado, you guys go make it a blessed day, and thank you very much, Alex and Kyle, for joining us today, and thank you all for investing in your knowledge, making yourself more valuable. Like Albert Einstein once said, don't seek to be successful, but seek to be valuable. The more valuable you are to others, your customers, your teammates, and yourself, the more successful you're going to be. So go out there, seek to be valuable by getting in on more of these training opportunities and learning opportunities. As you grow your value, you'll grow your business. Thank you so much for joining us today. We appreciate you joining us here at the Soligent YouTube channel. And thank you again, Fortress Power.
Thank you, Josh.
Thanks, everybody.